Hello friends, welcome to the ATC Double Cut. In today's episode, I'm going to talk about something that is happening every year at everywhere in the world where turfgrass is grown. That is nitrogen mineralization, or organic matter decomposition. As the organic matter in the soil decomposes, some nitrogen is released. And that, of course, is important because the amount of nitrogen that the grass can get, either from fertilizer or from the soil, will have a very important impact on how much the grass can grow. And that, of course, has a big effect on turfgrass performance. So I had some questions about this that were sent to me last week on the ATC Turf Discord that a few people are active in and asking questions and giving answers and sharing information. And you can find the ATC Turf Discord. You can find that at the top of the ATC website or in the About page on the ATC website. You can find a link to that Discord if you like that sort of thing. Anyway, the question was about how to estimate the amount of nitrogen that would be mineralized in a year in Melbourne, Australia. And that's something that I wrote a blog post about today with the title Estimating Nitrogen Mineralization, an Example. And I will explain two ways that this can be done. This is something that you might want to read about for reference, but if you're watching this or listening to this, I'm sure I can explain it clearly, and you will understand the concept behind this. And then if you want to try to figure this out for your own site, you might want to grab a piece of paper and a calculator and work through the simple math. But I will explain it in words and explain it so that you understand, I'm sure, how this works. You never decompose all the organic matter in the soil in 1 year. If you have some organic matter in the soil, it's something that stays in the soil for a long time. A little bit of it decomposes, and you can expect from 1% to 4% of the organic matter in the soil to decompose in a single growing season, a single year, basically. In very cold places, in the world, like Iceland, for example, or the northern parts of the Scandinavian countries, or the northern parts of Canada. In areas like that where the temperatures are cool, you won't have so much microbial activity for such a long time in the year. So you tend to have less decomposition. So you'll be closer to that 1% number that's the minimum value. And then in warmer places, if you go to Texas or Florida or southern Italy or Dubai, places that have a higher temperature and a longer time in the year with warm temperatures, you would expect to see more rapid decomposition. More of the organic matter in the soil would decompose. And now you might be closer to the 4% annual number. So you can think of this, and I put a direct link to this blog post. The title is Estimating Nitrogen Mineralization, an Example. I put a direct link to that in the show notes. And in the show notes, you will also find, or in this blog post, you will find some links to a couple of other references about this. So you will definitely be able to figure it out. So there's just a couple of things that we need to remember. Not all of the organic matter in the soil decomposes in 1 year. You can expect it to be somewhere between 1 to 4%. And you can expect that the organic matter in the soil contains about 5% nitrogen. And now we already have enough information to calculate on a per area basis how much nitrogen can be mineralized. Mineralized means it goes from an organic form into a inorganic or mineral form that the plant can use. So it goes from an organic form in the soil organic matter to something like nitrate or ammonium, which the grass can easily use. That's what mineralization is it's going from an organic form to a inorganic form. Because those are the only two numbers you need to know, basically. The organic matter in the soil is 5% nitrogen. You can expect at your site from 1 to 4% of the total organic matter that's in the soil to decompose in 1 year. So now you just have to figure it out based on the depth of your soil and based on the bulk density. This is really easy with the metric system, so I kind of do it just in my head. And I know if you're listening to this and you don't use the metric system, you might not be able to very quickly figure out how to do this in your head, or maybe there's other tricks that you can use with acres or pounds per 1,000 square feet or something that allow you to do it. But here's how it works in metric. I always like to work with a square meter as the base unit. I know some people prefer to use other base units. I like to use a single square meter. That's basically a square yard. And that is 100 centimeters by 100 centimeters. That's the dimensions. So it then, for turfgrass, I like to have a root zone that is 10 centimeters deep. I like to consider and do the math about a root zone that's 10 centimeters deep. So now we have a volume of 100 liters, and we also have a volume of 100,000 cubic centimeters. Soil bulk density, which is the mass per volume, is generally, for a loam soil, it might be about 1.2 grams per cubic centimeter. But for a sand that doesn't have very much organic matter in it, you'll have a bulk density of about 1.56, maybe up to about 1.63. It depends how the sand packs together, but it's generally, I often use the number 1.56. And then when you add some organic matter to it, that reduces the bulk density. You can calculate that exactly. I often just assume that a new root zone that doesn't have so much organic matter in it will have a bulk density of about 1.5. So that means that our 100 liters of volume of soil in that 1 square meter, it has a mass of 150 kilograms. And from that, if we know that we have, let's say, 2% organic matter, then we multiply 150 kilograms times 2%, and that tells us how many kilograms of organic matter we have. And we then multiply that by 5%, and that tells us how much nitrogen we have. And then we multiply that times 1%, and it tells us how much nitrogen could be mineralized in 1 year. Or we multiply it by 4%, and that tells us how much nitrogen could be mineralized in a year. So it's really pretty simple, and maybe for most people, the tricky part would be getting your soil tested to get the organic matter number, and then figuring out what your soil mass is. If you just want to guess, you might say that it's 150 kilograms if you don't know your bulk density. So anyway, I explained that in this blog post that I'll put a direct link to, and I link to some footnotes that go down and provide some additional information. I've calculated in the past that if you're in a temperate region, someplace like Portland, Oregon, or Chicago, Illinois, or London, England, if you go to a temperate region that gets warm in the summer and gets cool in the winter, you might expect for every 1% of soil organic matter that you have in the top 10 centimeters or top 4 inches of the root zone, you could expect to have about 2 grams of nitrogen per square meter mineralized in a year. That's 0.4 pounds of nitrogen per 1,000 square feet. If you have 2% organic matter in your soil, then you could expect about 0.8 pounds per 1,000 square feet, or 4 grams of nitrogen per square meter, or 40 kilograms of nitrogen per hectare. If you happen to have an extremely high for a putting green, it would be extremely high to have 3% organic matter in the top 10 centimeters of the root zone. But if you happen to have that, that would bring you up to over a pound of nitrogen, more than 50 kilograms of nitrogen per hectare expected to be mineralized in 1 year. Of course, in fairway soils, it's common to have that much. It's common in fairway soils to have 3, 4, 5, 6% organic matter in a fairway soil. And if you happen to have that type of soil, then you can see that you may have 100 kilograms of nitrogen per hectare or 2 pounds of nitrogen per 1,000 square feet could be mineralized in a year in that type of fairway soil. And in those type of soils, you would have to, or you could go without nitrogen fertilizer for many times in the year, because for much of the year, you would find that the grass already grows well enough because it's well supplied with nitrogen through natural processes. I included a chart in here, and this is a chart that I make this type of chart for ATC soil test reports. And the chart that I'm showing on the screen now has a title, Estimated Nitrogen Mineralization. And it gives an annual total, and it uses site-specific temperatures, and it breaks it down month by month. So I calculated this for a starting organic matter content of 2.5%, which was the example that we were working with in our discussion in the Discord server last week. And this conversation was about how much mineralization could happen in Melbourne, Australia. So I used air temperatures from Melbourne, Australia, and I use a different set of equations that are much more complicated than this general 1% up to 4% in a year mineralization. And I calculate using a different set of equations that loops through the year day by day. And it calculates how much mineralization you could expect on a day given the type of temperature that you would expect on that day. Then I add all those days together and I get monthly totals. So on this chart, I'm showing the estimated nitrogen mineralization that would happen with temperatures in Melbourne, Australia, and starting organic matter content of 2.5%. And it comes out to be a total amount expected over the year of 3.9 grams per square meter, which is about 0.8 pounds of nitrogen per 1,000 square feet in 1 year, which is a substantial amount of nitrogen, I think. And because it's in the southern hemisphere, then the winter is in the northern hemisphere summer. So the lowest amount of mineralization is expected in June and July, and the greatest amount of mineralization in Melbourne would be expected with the type of temperatures that they tend to have there. The greatest amount of mineralization would happen in December, January, and February. And then March comes very similar to February. So if we would look at that, just from November through to March, you would expect 2.1 grams of nitrogen, or 21 kilograms per hectare, would be expected at this location. And we don't really know exactly what's happening in the soil because it also depends on your soil pH a little bit. It depends on your soil moisture a little bit. And it depends on the nature of your soil organic matter a little bit. And it depends on the type of temperatures that you have in any given year versus what the temperatures have been in the past. But this type of about estimate, the estimate of about how much nitrogen we can expect to be mineralized, can be really useful when planning fertilizer applications and just trying to understand what's going on with the growth. I really like to measure the clipping volume and check how much the grass is growing. And if the grass is growing more than you expect for the amount of fertilizer that you've applied, you can also think of that as probably there's something going on with the mineralization that is leading to some of that increased growth. So that is a topic that comes up every now and again. And I've got, I think, 3 or 4 blog posts that discuss this topic and come at the issue from various angles. And those are all on the ATC website. And if you go to the blog post about, what did I call this one? The one that I'll put a direct link to here has the title of Estimating Nitrogen Mineralization, an Example. So if you go to that one and you scroll down, it will show some recommended posts. And let's see. I can't bring that up on the screen right now, but the related posts at the bottom are estimated nitrogen mineralization from soil organic matter and N mineralization, N input accounting, nitrogen rain and starting point estimates, all blog posts that are related very much to this idea of mineralization and how much nitrogen may be mineralized at your location. So that is something that I hope everyone will have a really good understanding of, because it is really, really easy to get that estimate. I'll tell you one more time just how easy it is. You know how much organic matter you have in the soil. You figure out the mass of the soil. You multiply the mass of the soil times the organic matter percentage, and that tells you the mass of organic matter. You take then the mass of organic matter and multiply that by 5%, and now you know the mass of nitrogen. You know the quantity of nitrogen in organic form in the soil. And now you multiply that by 1% to get a low estimate of how much will be mineralized in 1 year, and you multiply that by 4% to get a high or upper end estimate for the year. Actually, I will show you one more thing. I figured out how to get those related posts to show. So those are showing now. You can see the related posts on the screen, which, as I mentioned earlier, are all related to nitrogen. And I'll show and read the final sentence of this blog post. If I work through for this location in Melbourne with that amount of organic matter in the soil, if we multiply the resultant nitrogen that's in that organic matter by 1%, then we get 1.7 grams estimated mineralization. If we multiply by 4%, we get a maximum of 6.8. And when I calculated it daily, like I do for the ATC soil reports, when I calculate it daily and sum the values every day over the course of the year, we get 3.9. So I wrote in the final sentence, I said, notice that the 3.9 grams falls nicely between the minimum estimate of 1.7 and the maximum estimate of 6.8. And that's why I like to do it my way, which is calculating it daily and summing it, which is a series of equations in a loop that loops through the year. I like to do it that way, and I think what you see, if you're one of ATC's soil testing clients and you get that as part of your soil test report, it is a nice calculation to have, because it's so much more precise, even though it's still an estimate. And even though we still don't really know for sure, it is so much better than saying it's somewhere in between 1% up to 4% of the total organic material. And I feel like I'm in a hot place in the world, or I feel like I'm in a cold place in the world. Because actually, when I've calculated this for Iceland, sometimes it seems to be less than 1% mineralized. And for pure tropical places like Bangkok, I think it can be a little bit more than 4%. So that 1 to 4% is very much about just like a ballpark figure, and calculating it daily is nice and precise, although it's still not reality. It's just the output of an equation, but it is what seems to me a useful output of an equation. That's all for now. I will be back again soon with more interesting turfgrass topics and turfgrass information, I will sign off now for ATC from Bangkok, Thailand. I'm Michael Woods. Bye-bye.